2022 class, we have come this far as far as the revision of this paper is concerned. We are now on question 4, and we are going to go through this together. We hope the voice behind the memo is going to fix some of the misconceptions and errors that you have. Now, question number 4, we are given y is y plus 3 into x minus 2 is equal to 4. And they are saying express 4.1, the function in the form a over x minus p plus q. And what we know is that this is a hyperbolic function, and this question is under functions. So to write it in that way, we are saying we have to divide by the bracket x minus 2 both sides, so that we put it in the position it's supposed to be. So it's y plus 3 is equal to 4 over x minus 2. And then what is left is just to make y the subject by subtracting 3 from both sides. So therefore y is equal to 4 over x minus 2, positive 3 becomes negative 3 on the other side. So our f of x will be equal to 4 over x minus 2 minus 3. That is how we treat 4.1. 4.2, write down the asymptotes. The asymptotes, these are two equations on which f of x is not defined, and we know that equations on the Cartesian plane, they are defined in terms of x and y. So we have the vertical, which we will take from this. We know that when x minus 2 is equal to 0, f of x will not be defined. So we are saying x minus 2 will be equal to 0. That means the equation, therefore x will be equal to 2. So when x is 2, f of x will not be defined. And that is the vertical asymptote. Then we have the horizontal asymptote. If f of x is equal to negative 3, x will not be defined. So we are simply saying f of x is non-mass to y. So when f of x is equal to negative 3, and this is the horizontal, that's the horizontal asymptote. Alright? 4.3, they are saying write down the range. Now the range, we are trying to define the values of y, or the values of f of x for this function. And with hyperbolic functions, we know that the only value of y that this function or that y cannot assume is y equal to negative 3. X is not defined along that line. So we are saying y can take all other values. So y is an element of real numbers, but y cannot be equal to negative 3. Okay, then 4.4, we are asked to determine the y-intercept. 4.4.1, we need the y-intercept. And we get the y-intercept when x is equal to 0. So we are just going to substitute. Y will be equal to 4 over 0 minus 2 minus 3, and that gives us negative 5. So the y-intercept has the coordinates 0, negative 5. Okay, 4.2, we need the x-intercept. So this comes when y is equal to 0. So we are saying 0 is equal to 4 over x minus 2 minus 3. Now this is an equation with fractions. You must be really good with solving this equation. You can either take minus 3 to the left side, it will be 3 is equal to 4 over x minus 2. Then you multiply both sides by the denominator x minus 2, so it's 3 into x minus 2 is equal to 4. That is 3x minus 6 is equal to 4. 3x is equal to 10. Therefore, x is equal to 10 over 3, which is 3 and the third, or 3 comma 3, 3. Alright, so the graph is going to cut the x-axis at 10 over 3, 0. Alright, then 4.5, we are being asked to sketch the graph. So at times it's good to have a rough sketch before you really do the graph. The rough sketch of the graph, we have said the asymptotes, it's x is equal to 2 and y is equal to negative 3, that is down there. And then 4 indicates or tells us that the graph should be in the first quadrant of the asymptotes and the third quadrant. So we're expecting our graph to be like this and our graph to be like this. So that's what we just need to show now on the graph. So we have a scale of some sort so that your sketch precisely will be a bit more accurate. So x is equal to 2, that's the vertical asymptote. Okay, so the point of intersection of the asymptotes is 2, negative 3. Then we have said it cuts the x-axis at 10 over 3. So 10 over 3, that's 3 comma 3. So we can put it there. And at times it's good to label so that the one who will be marking will definitely know that you knew what you were doing. And then thereafter, we have said the graph will be going towards the asymptote and it will be going towards the asymptote, though it will never touch, no cut. Alright, and then on this side, we have said it is going to cut the y-axis at negative 5. So, and that is what the examiner was expecting, since they just said sketch the graph of the function showing clearly the asymptotes and the intercepts with the axis. So that's what we have done. Alright, then 4.6, the last question. If g of x is equal to f of x minus 2 plus 5, determine the coordinates of the point of intersection. The image, determine the image. Determine the coordinates of the point of intersection of the asymptotes of g. Alright, so g of x is coming after some transformation on f of x. So we must be able to read the transformation here. Now x minus 2, that is a horizontal transformation of 2 units to the right. So we are saying the point of intersection of the asymptotes is here at 2, 3. At 2, negative 3. So if we move this point 2 units to the right, it is the x coordinate that is affected. That means it will be 2 plus 2. And then the 5 is the vertical shift, and it's positive, so it's 5 units going up. So when we go up, it is the negative 3 that is being affected. So we are saying it will be negative 3 plus 5. So this will give us 4, 2. So the asymptotes of G will be crossing at point 4, 2. So that is how you were supposed to answer this question. All right, we'll continue to question 5 in a while.